All right, hey, Honors Chemistry. This is going to be part 2 of the Unit 5 review. These questions are a little bit more involved, so make sure that you're paying attention. So let's look at question 4, letter C. It says a 4.07 gram sample of NaI contains how many atoms of Na? All right, the moment you ask for atoms, you have to think about Avogadro's number. 6.022 times 10 to the 23rd atoms are found in 1 mole. So if I have moles, I could go to atoms by multiplying by this number. I'm going to call this Na. I could go from moles to atoms by multiplying by Na. I could go from atoms to moles if I divide by Na, and Na is Avogadro's number, 6.022 times 10 to the 23rd. All right, I need moles. Notice how in this, there's nothing about grams. I need moles. So I'm going to do calculations kind of like how you do. Grams over molar mass is going to give me moles. So in not doing dimensional analysis, if I have 4.07 grams of sodium iodide, and you could look on the periodic table, the molar mass of NaI, if you look up all the information on the periodic table, it's 149.9 grams per mole. So that's 1 sodium, which is like 23, and 1 iodine, which is like 127. Altogether, that's 149.9 grams per mole. Now, I have 4.07 grams of NaI, and the molar mass is 149.9. So if I want moles of NaI, it's equal to 4.07 grams over 149.9 grams per mole. Now, if I do that calculation correctly, this is going to give me moles. And so I'm going to do that. 4.07 divided by 149.9, and I get a pretty small number. I'll show you what it looks like not in scientific notation. 0.0272, I'll round it. So this is 0.0272 moles of NaI. Now, the question's asking for atoms of Na. Now, remember my formula has 1 Na and 1 I. So if I had 1 mole of NaI, I would have 1 mole of Na and 1 mole of I, right? So remember when we talked about formulas in the very beginning, because it's going to show up later. NaI, 1 NaI has 1 Na and 1 I. And so now if I want to figure out how many atoms of Na there are, and I have moles of Na, what I could do is, I know that for every 1 mole of NaI, there's 1 mole of Na. So this moles of NaI is equal to moles of Na, because it's 1 to 1. If I had 2 NAs in here, I'd be multiplying this number by 2. I'd have twice as many Na. And now that I have moles of Na, if I want to go from moles to atoms, I multiply by Avogadro's number. So 0.0272 moles of Na times 6.022 times 10 to the 23rd atoms per mole. And I arrive at an answer of 1.63 times 10 to the 22nd atoms of Na. Coincidentally, that's also how many atoms of I there are, and also coincidentally, that's how many molecules of Na there are. All right, let's try this again with letter D. It says how many atoms of chlorine are there in 16.5 grams of iron 3 chloride, which is FeCl3. Make a note, again, for 1 FeCl3, there are 3 Cl's. I'm going to have to use this relationship later. So in order for me to figure out atoms, again, if the question is asking about atoms, or the question gives you atoms, like in the next one, I need Avogadro's number. If it said moles of atoms, that's different. If it said grams of atoms, that'd be different. If it just says atoms, I need Avogadro's number. So for me to use Avogadro's number, I need moles. So I'm going to need to convert these 16.5 grams of FeCl3 to moles. 1 mole of FeCl3. The molar mass of FeCl3, if you look it up and do it, is 162.3 grams of FeCl3. And so if I do this math, I get 16.5 divided by 162.3, because it's times 1 divided by that, I get 0.102 moles. 0.102 moles of FeCl3. And now, kind of like where I'm at up here, if I have 1 mole of FeCl3, I'll have 1 mole of Fe and 3 moles of Cl. Because in the end, I'm going to need atoms of chlorine, which is Cl. So what I'm going to do here is I'm going to figure out how many Cl atoms there are. 3 moles of Cl for every 1 mole of FeCl3. Since there's 3 times the amount of chlorine in this formula, there's going to be 3 times the amount of moles. So if I do that, I'll get 0.102 times 3, and I get 0.306 moles of Cl, because there's 3 times the amount. But the question's asking for atoms, so now I have to multiply by Avogadro's number if I want the total number of atoms. And I'll get the number 1.84 times 10 to the 23rd atoms of Cl. Okay, that is the answer. Now on the next question, I'm going to go backwards. I have 100 million atoms of gold. What is the mass? And then it says, could you mass this on a balance? 100 million is 100 times 10 to the 6th atoms. Okay. And 100 times 10 to the 6th times 10 raised to the 6th is 1.0 times 10 to the 8th. 1.0 times 10 to the 8th atoms of Au. Now, it wants the mass. I don't have a relationship yet that helps me go from atoms to mass. In any of our math, we need moles to get mass, or we need grams to get moles. But if I have atoms now, the only way that I could get mass is by first, I need to get moles. So our pathway here is going to be going from atoms to moles. And then once I have moles, I could get grams. To go from atoms to moles, I'm going to divide by Avogadro's number. And that's going to give me moles. I said that up here. If I have atoms and I want moles, I divide by Na, which is Avogadro's number. And then now we should know what to do if I have moles if I want grams. So I'm going to divide by Avogadro's number. 1 mole of Au is 6.022 times 10 to the 23rd atoms of Au. If I do this, I'll divide this by 6.022 times 10 raised to the 23rd, and I get very small number, 1.66 times 10 to the minus 16th moles of Au. That's my moles. That's not my grams. That's not my number of atoms. My number of atoms were 100 million. To go from atoms to moles, I divide by Avogadro's number. So what I did was I took this number, I multiplied by 1, and I divided by this. Or essentially, I just took this number, 1.0 times 10 to the 8th, which is 100 million, and I divided it by 6.022 times 10 to the 23rd, and I got this number. Now, if I want grams, we already know that moles times molar mass equals grams. So I'm going to do 1.66 times 10 to the minus 16th moles. Don't be afraid that it's a very crazy, ugly number. Don't be afraid that you got 10 to the minus 16th. You're supposed to. I'm going to multiply by the molar mass of gold, which if you look on the periodic table, gold on the periodic table somewhere in the middle, you get 197 grams per mole. Moles times molar mass is going to give me grams. So I'm going to multiply these two numbers, and I get a very small number, 3.27 times 10 to the minus 14th grams of AU. That is very small. And then the second part of this question said, could you mass this on a balance? No. This number is way too small that I would not be able to mass this on a balance. So I'm going to say no. Way too small. All right, I'm going to end the video here. In my next video, I'll work on doing questions 5 and 6.